Here's another application of Beer's law. So this application is now dealing with percent transmittance. So there's an equation that we can use to help us find absorbance from percent transmittance, or find the percent transmittance just given the absorbance. So the equation we're going to use is absorbance, which is indicated by the big A, is equal to, sorry I'm a little bit off the page, is equal to 2 minus log of my percent T. So let's go ahead and look at this. This is number 6 from Beer's law problem set. So what I'm given is a set of concentrations for the standards, and then I'm given a set of absorbances and asked to find the percent transmittance. So I'm going to use the equation absorbance equals 2 minus log, and what it's asking for here is the percent T. So I can go ahead and put an X in for that guy. So the first step, I don't like negative logs. They don't play very nice. So I need to get rid of that negative log. So we're going to go ahead and work with this first absorbance of 0.00. So I have 0.00, and if I look at this, I've got minus log of x. So if I add a log of x to both sides, then I've rearranged the equation to have it say my absorbance of 0 plus log of x is equal to 2. Well, I can subtract away the 0 if I need to, or the absorbance of 0.00, and I end up with log of x is equal to 2. Well, in order to solve this, I need to get rid of the log, so I can divide it away. And what I end up with is I end up with x equals 2 divided by log. And that gets kind of complicated, or some people look at that and say, uh-oh, where do I go from here? But it's helpful to remember that something divided by log is just the same as taking the antilog of that number. And our calculators will do this very easily. So the log key on my calculator just says log, but if you look above it, or if the shift function, it has 10 to the x. And essentially the antilog of a number is just taking 10 to that power. So I would go ahead and hit shift log and saying, okay, 10 to what power? And in this case it's just 2. I hit equals and I get the value 100. So if I look at this, it's saying, hey, if my solution is absorbing 0, how much of that light is actually getting through? Or what is the percent transmittance for that particular solution or standard? If it's not absorbing any of it, then that makes sense that 100% of it is getting through my sample. So let's look at the next one, see if we can make this make more sense. So the absorbance I'm given is 0.080, and I'm asked to find the percent T. So A equals 2 minus log of my percent T, or 0.080 is equal to 2 minus log of x. So just doing algebra, I got 0.080 plus log of x is equal to 2. And I need to get this guy on the other side. So I have log of x is equal to 2 minus 0.080. I get rid of the log there by dividing it out, and I have x equals 2 minus 0.080 over log. And I want to make sure I do that math first. So 2 minus 0.080, x is equal to 1.92 over log. So I go to my calculator and I say, what is the antilog of 1.92? And I get this number 83.176. X equals 83.176. Or in other words, the percent transmittance for that standard was 83.176%. Or I can round that to say 83%. And that's all there is to it.